In this video, we're going to talk about finding the dot product of two vectors. So what we have here is vector u, which is 3, 5, 2, and vector v, which is -1, 3, 0. So when you want to find the dot product of two vectors, it's written like this: u dot v. And to do this, all we're going to do is multiply the vx components. So this is going to be 3 times -1, and then we're going to multiply the vy components, 5 and 3, and finally we're going to multiply the vz components. So it's going to be 2 times 0. And we're going to take each of those products and then we're going to add them all up. And so the final answer to a dot product of vectors is just going to be a scalar, a single number. So what we have here is -3 plus 15 plus 0, and we're left with u dot v is equal to 12. So it's a single number, just 12. We can try another example here. This time we have vector u, which is 2, 9, -1, and vector v, which is -3, 1, -4. So again, to find the dot product of two vectors, we just multiply the corresponding components. So in this case, the vx components are 2 and -3. Then we're going to add the product of the vy components, which is going to be 9 and 1. And finally, we add the product of the vz components, -4. So when we do this math out, we get -6 plus 9 plus 4, and this is going to give us 7. If our vectors are written using the standard unit vectors I, j, and k, then we can find the dot product basically the same way. This vector over here, p, is equal to 10, -4, 7, so we can rewrite it this way. And then the vector q can be rewritten as -2, 1, 6. So the I vector corresponds to the vx component, j corresponds to the vy, and k corresponds to vz. Now we just proceed as usual. So finding p dot q is simply a matter of multiplying the vx components, 10 times -2, then adding the product of the vy components, -4 and 1, and then finally adding the product of the vz components, and 6. So this is going to be -20 minus 4 plus 42, and it comes out to be 18 as our dot product.